Welcome everyone to today's Smith in the World panel. My name is Emily Beaudry. I'm the Praxis Internship Manager here at the Lazarus Center for Career Development at Smith. This is the sixth and final panel of the 2026 Smith in the World Conference Series. Throughout the month of January, we have featured student panels that align with our career communities, including education, nonprofit, and social impact, health professions, business, finance, consulting, and entrepreneurship, government, law, policy, and international affairs, and arts, media, and communications. So we welcome everyone joining us today, including our students, prospective students, former Smith in the World presenters, faculty, staff, family and friends, supervisors and colleagues, everyone else. Thank you so much for joining us to hear from these outstanding students. A little bit about this conference. The Smith in the World Conference celebrates students' off-campus experiential learning, including internships, community service, and research. Students reflect on how their experiences have impacted them and enriched their academic and professional paths. This conference is a part of the college's spring showcases, and you can learn more about that on Smith's website. I'll drop a link in the chat a little later. So our panelists today are going to give short presentations about their off-campus learning experiences, focusing on their projects, the impact the experience had on them, and how Smith prepared them for success. And we have a really interesting range of STEM experiences to hear about today. And I'm really honored to introduce our four panelists. First, we're going to hear from Michelle Lawson, class of 2026, then from Lucy O'Brien, class of 2026, Chloe Dyehouse, class of 2028, and then finally, Kerry Seekamp, class of 2026. Before we get started, I want to let you know that this session is being recorded, so we ask that you keep your microphone on mute during the presentations. You're welcome to submit questions via the chat tool, and we will field all those questions after all the students have had a chance to present. And at that time, you're also welcome to unmute yourself and ask questions directly if you'd rather. So with that, I'm going to hand it over to our first panelist, Michelle.
Thank you, Emily. I will go ahead and share my screen. I hope everybody can see my presentation and can hear me pretty well. Awesome. I'm so excited to speak with all of you today and share my journey through Smith. As Emily mentioned, I'm class of 2026, so I've been here for 4 years. And through these 4 years, I've gotten to gather so many experiences that have ended up with me getting a full-time offer as an AI engineer out of college. And this is a story of how that happened. This all started way, way before I actually landed the offer in my first year. The moment I landed at Smith, right after my first year, I got to gather some non-academic experience by doing research with this professor over here, Dr. Pablo Bolton, using Smith's undergraduate research funding program. It was my first ever technical project in computer science, and it helped me gain credible experience. Apart from that, I also went for a bunch of competitions, pitch competitions, and other courses in other schools like MIT, with a focus on developing skills that were project-based across a variety of areas, some in computer science, but some in investment and finance as well. And as I was doing this, I actually discovered conference funding opportunities. I learned that Smith has the resources to fund conference attendance, especially if it has to do with leadership or the field that you're learning. And this changed everything because I took that opportunity and I started putting myself out there a lot. In my third year, which was 2024, I attended the Grace Hopper celebration, the Afrotech conference, and TechCrunch Disrupt all in 1 year. I got to really open my eyes to what recruiters were expecting from students, what other students in other colleges were doing, and what professionals who had been working in the field for 10, 20 years had done to really establish their professional career. Also, I got the funding for these trips from 3 centers at Smith College: the Lazarus Center, the Conway Center, and the Wurzel Center. If you are here and you are a current student or a prospective student, I would definitely encourage you to check out the funding grid because you can get funding for a lot of things. And the conference funding really changed a lot for me. In fall 2024, right after I'd come from the Afrotech conference, I saw a LinkedIn post from a MongoDB recruiter about a product management internship that just opened. At this time, I had applied to about 50 internships before I saw this post. But for all of those internships, I had just applied online, and all the conferences that I had attended had shown me the value of really interacting with people, sort of human to human. So I decided to take a different approach for this opportunity. First of all, I applied within 2 days of seeing the post and within 2 days of the job posting being, available and online. And then I sent a LinkedIn message to the recruiter. It was kind of obnoxious, but I was really selling myself here as to why I am the perfect candidate. And I also followed up with her over email, sending another email with bullet points as to why I'm perfect for the role. The whole purpose here was that the recruiter would see me about 3 times through the online application, via LinkedIn, and via email as well. And I think that it worked because on November 25th, the recruiter called me and did my first recruiter screening with her, which then led to my first behavioral interview for the role in December 2024. And then I had 3 back-to-back interviews for the role in January of 2025. Throughout this process, I made sure to prepare intensively using the resources at the Lazarus Center and also using a lot of the connections that I had made when I went for all of these conferences in fall of 2024. And it worked out great. In January 2025, I got an offer to be a product management intern at MongoDB. I was super excited, so I accepted it after talking with my parents and my professors and everyone around me. I also made sure to check in with the International Students Office to get my documentation all set up, and they were super, super helpful with that. And then I started the internship in summer of 2025. I made sure that I kind of kept 3 principles: being action biased and being proactive, making sure I was solving problems creatively and not just doing like the bare minimum just to get by, and over communicating every single thing that I was doing so that it was clear to my managers and mentors what I was doing throughout the internship. Um, this also encouraged me to embrace flexibility. This is the team or the managers and mentors and other engineers that I was working with. Fun fact, my manager, who's the woman in the pink sweater, is actually a Mount Holyoke alum. So it was really cool to see the 5 college network extending way outside of the Pioneer Valley. But while I was in the internship, there was a bit of a mix-up where I was assigned tasks as an engineering intern instead of a product management intern. I didn't complain or say like that's not my job. I decided to handle it joyfully and just give it my all and give it a try anyway. And that approach would change everything because my manager then asked me at the end of the internship whether I wanted to be in product management or AI engineering. And I decided that AI engineering turned out to be a lot more fun, even if it was an accident. And this led to another offer for a full-time role as an AI forward deployed engineer in fall of 2025 instead of a product management or product manager if I had just done the typical traditional job description for the internship. This meant a higher salary. It meant I got to do work that I really loved. I was really passionate about the work I was doing. It was so cool. Would happily talk to anybody about it afterwards. And I also have the opportunity to work remotely and had the flexibility to choose to move to San Francisco afterwards. From all of this, I have like some key takeaways that I think really allowed me to make the most out of the journey, being action biased and deciding to build my own stuff or do my own stuff outside of the academic curriculum. Interacting with people human to human makes a huge difference. There's so much stuff on the internet right now and in online interactions via job applications and AI, but human to human helps recruiters and other people know that you're real and you're someone they might want to work with. Putting myself out there, especially using Smith's funding resources, they've been super, super helpful, and I cannot say how much I'm grateful. And staying open and curious and flexible about different areas, from computer science research to investment banking to product management to AI engineering. That's how I got to end up on what I really enjoy doing. So this has been my story. I think it's a typical Smithy story. We're really creative, we're really action biased, and we make the most out of all the resources that we have. If you want to explore more Smith resources, definitely check out the Lazarus Center, Conway Center, Rental Center, International Student Office. And if you want to connect with me on LinkedIn, you can scan the QR code as well. Thank you very much.
Thank you, Michelle. That was fantastic. Thank you for all the free promotion of the Lazarus Center too. We appreciate that. Next up, we're going to hear from Lucy O'Brien.
All right, I hope everyone can see my screen and hear me. All right, hello everyone, my name is Lucy O'Brien and I'm a senior here at Smith. And today I'm going to be talking a bit about my summer job at the Fred Hutch Cancer Center in Seattle, Washington, where I worked on a project using machine learning to track the spread and evolution of viral diseases. Okay, to start, I just want to talk a bit about myself and why I decided to pursue this opportunity. So here at Smith, I study both history and statistics and data science as a double major. And while I knew that I wanted to major in these fields from essentially my first day of college, as I was starting my junior year, I realized that I had no knowledge of what statistics look like outside of the academic setting. My first 2 summers, I worked jobs totally unrelated to stats, including a food service job after my first year and a Praxis-funded internship as a research assistant for a history professor at Georgetown after my sophomore year, just the pictures you see on the side here. So as I was approaching kind of like the second half into the end of my college career, I knew that I wanted to have some sort of experience in applied statistics before I graduated. I knew that this wouldn't only help me like grow my resume before I started applying for full-time positions, but also help me understand if I really wanted to pursue jobs in stats and data science at all. When I began looking for possible summer jobs, I primarily focused on jobs that in the field of epidemiology and to a lesser extent biostatistics. I'd taken a data science class in this field previously during my sophomore year and had really enjoyed it, so I already had some familiarity with the field. I also knew that this specialization overlapped with my interest in the humanities and history because I studied the history of medicine and disease in that department. So over the winter of my junior year, I began applying to a bunch of research internships in biostats and epidemiology across the country. And by February of my junior year, I landed a position at the Fred Hutch Cancer Center in Seattle, where I joined the Summer Undergraduate Research Program, or SURP. So SURP is a program designed for rising seniors who want to pursue scientific research specifically relating to medicine or biology in some way. Each of the interns in my cohort, pictured here, were placed in a lab at the center to complete a research project with a faculty member or a mentor. I specifically was placed with the Bedford Lab, a group in Fred Hutch's Vaccine and Infectious Disease Division that focuses on the evolution and epidemiology of viral diseases. The lab also works to forecast the evolution of diseases, which helps larger organizations like the WHO decide things like how to structure a flu vaccine for a given year. So while most of my peers in the cohort were placed in wet labs, that kind of like bench science you might think of when you think of biology, my lab was entirely computational, focusing on the statistical analysis of disease evolution and spread across space. More specifically, my project was focused on developing a machine learning algorithm that could be used to infer the phylogeography of diseases. So here, phylogeography refers to the study of the geographic distribution of genetic lineages and how these lineages came to be. So essentially, it's a process of going from genetic samples, that kind of like ATCG thing you might remember from high school biology, and then analyzing the little mutations between individual samples, and from that deriving an evolutionary tree. And then from this tree, including geographic data so that you can then map the spread of diseases. So here on the side, I have some examples I took from the Bedford Lab website of the lab's work with COVID-19, both tracking the evolution of it and its spread across the world. So traditionally, the process of phylogeographic analysis is built off the assumption that all disease evolution follows this tree-like structure. However, this isn't always strictly the case. And if you keep with this assumption, the analysis can basically entirely fall apart. Additionally, it can be very computationally taxing, which just means it's very, very slow and can get expensive if you have a lot of data points. So to address these issues in the field, some researchers have been moving towards machine learning to fill in the gaps. This is exactly what my project did. In this way, I was essentially a guinea pig for my lab, because when I started last summer, no one in the lab was focusing on machine learning approaches at all. My project, along with the research of a postbac in the lab, who joined the same week that I did, were essentially testing grounds for the lab to see if this would be a viable path in the future. So in particular, I was tasked with analyzing genetic data of a simulated outbreak of a disease that mutated and spread at a similar rate to COVID-19. I was given about 23,000 fake samples of this disease from individuals across geographic areas A, B, and C, with disease spread between all three of these fake regions. So the best way to think of these like fake regions is if they're real world places like cities or countries. So we could think of A, B, and C as instead cities like Northampton, Los Angeles, and Seattle. Because the simulated disease, like COVID or like the flu, spreads in person-to-person contact, the genetic data of a single instance of disease is going to be geographically specific in some way. So someone in Northampton's illness is going to be more closely related to other people in Northampton's versus someone in LA. So while there may be crossover, for example, someone from Seattle is sick and then flies to Northampton and infects people there, there'll be geographically specific mutations and traits within the genetic data. So my task was to create a model that could learn, in quotes, the intricacies of these mutations and traits. Once my model had learned these details, it should hypothetically be able to identify where a given sample came from based off its genetic data. For example, if I gave this model a sample taken from an individual in Northampton or region A, it should be able to correctly predict that it was from there and not B or C or not Los Angeles or Seattle. So here are what some very early sketches of what my project looked like in the first few weeks of my internship. When I first got to the lab and started learning more about what my project would be, I felt totally overwhelmed. I knew nothing about how to build a neural network at all. I had no experience with machine learning. I was supposed to do all this in Python, which I had no training in. And to top it all off, while I'd taken that biostats class I'd mentioned here at Smith, I had no understanding of evolution or virology beyond what had been covered in my 11th grade biology class, which I'd also taken during COVID, during the online year, so I remembered none of it. I also felt a huge amount of imposter syndrome compared to my peers in the program. Basically, everyone else in my cohort had years of experience in research labs dating back to their very first weeks of college. While everyone was in a slightly new environment and in a new lab, they had a much deeper understanding of the norms of research and the work that they were doing. Compared to them and to the researchers in my lab, I felt like a total fish out of water. To combat this feeling of imposter syndrome, I tried to remind myself that I was there for a reason. I had to remind myself that my application wasn't picked out of pity for the poor HWC student, but because the lab's PI believed that I was the best fit for that group. When I reminded myself of this, I didn't want to wallow in my feelings of doubt, but prove to the people around me that they had made the correct decision. I spent the next few weeks of my internship pushing myself to learn as much as I could as I built the project up. I had meetings with my supervisor every few days, where I tried to ask questions, fill in the gaps in what I knew. I was really lucky to have an incredibly supportive lab behind me. My supervisor and my PI made it very clear that the internship wasn't supposed to be like free labor for the lab, but a learning experience for both them and me. They never made me feel silly or less than them for asking admittedly incredibly basic questions about biology and made sure to celebrate my progress every step of the way. I've heard a lot of horror stories of very unsupportive or just mean lab environments, and I'm very happy that this was the farthest thing from my experience. So with my renewed confidence and all the support from my lab, slowly but surely, the project began to take shape. So by the end of my internship, I was able to show off a working neural network model that could accurately predict the origin of a simulated viral sample with over 70% accuracy. A comparable tree-based model, that kind of computationally expensive and slow thing that we were trying to move away from, only scored about 33% on the same data. In this context, it was about as good as rolling a die and going with that. At the end of my internship, I had one last hurdle, 2 presentations, one over an hour-long lab meeting that I was hosting and another at a competitive poster session with the other interns in my cohort. Before doing both, I was crazily nervous and practiced endlessly to literally anyone who'd listen. However, while giving my presentations, I was surprised to realize I actually did know what I was talking about. After 9 weeks of setting up and growing the project, I no longer felt just as much imposter syndrome and started to feel much more confident in my abilities and my knowledge. As I said in a text to my best friend, the minute I finished that hour-long presentation, I only felt a little bit dumb rather than a total fish out of water. As my internship wrapped up in the end of August, I headed back to Smith a week later. As I left Seattle, I knew that I didn't just have a deeper understanding of statistics and machine learning, but also I knew what I wanted to pursue in the future. I now knew that I did enjoy working with statistics and epidemiology outside the classroom, and I felt more confident pursuing the field going forward. While I originally had a return offer going back to the lab in this upcoming summer, that unfortunately recently fell apart as the funding is very up in the air right now because it's disease research in this current climate. So I've recently been applying for positions in epidemiology and other positions at the intersection of epidemiology and public health to start after I graduate in May. I'm also currently considering applying to graduate programs in epidemiology following a gap year. I'm really grateful for the experience I had at Fred Hutch, both for how much I learned and how much I was pushed to learn more. I think this job was really invaluable to both my education and my work, and I'd be very happy to answer any questions y'all might have after we wrap up presentations. Thank you all.
Thank you so much, Lucy. That was fascinating, and I'm really glad to hear that you felt that imposter syndrome, but you pushed through it and you proved to yourself and everyone else that you could succeed there. That's awesome. Next, we're going to hear from Chloe Dyehouse.
Hello. Okay, I share my screen. You see that? Okay. Oh, good. All right. Hi, my name is Chloe Dyehouse, and I'm a sophomore biology major at Smith. Last summer, I experienced something transformative, the desire to never leave my workplace. I interned in an ecology lab at the University of Rhode Island under Professor Evan Pricer and studied bees, slugs, and native plants. The summer I spent there and the learning I did sparked a passion for entomology and pollinators that has since embedded itself into every aspect of my life. Beyond being head over heels in love with plants and bugs, I'm also a cheerleader here at Smith and an amateur woodworker. Many of you who spend time at Smith may have seen the picnic tables I built for the squirrels on campus, pictured here. I grew up in Rhode Island, where I volunteer at my local animal shelter and work at Dunkin' Donuts. I wasn't always interested in biology, however. In high school, my passion was for political science and social justice work. Applying for college, I put myself down as a government major. I felt confident in my ability to understand and write about policy and insecure in my comprehension of math and science. Only after being accepted to Smith did it occur to me that the things I was passionate about didn't need to be the same things I felt good at. At my Smith Admitted Students Day, I shadowed Gabby Immerman's horticulture class. Learning about plants, even just for a day, made me feel happy in a way I hadn't ever felt before in an academic environment. That day, I walked into the Smith greenhouses as a prospective government major and walked out a future biology major. Because I came to Smith with no prior experience in the field I wanted to study, I struggled to get an internship last summer. In fact, I only thought to reach out to labs in my hometown after unsuccessful attempts to intern here at Smith or in any of a number of NSF-funded opportunities. But my email to Professor Evan Pricer at URI turned out to be one of the best decisions I had made all year. And thanks to the Smith Praxis program, I was able to transform a volunteer internship into a paid one. In the lab, I worked primarily under PhD student Ren Johnson, traveling around URI to study pollination and phenology of native Rhode Island plant species like rhododendron, black cherry, cranberry, and several others as well. We used vial and net catching to take specimens back to the lab and ID them, trying to learn about who pollinates each of these plant species. I learned skills like insect pinning and bee identification. Many days were long and grueling, 8-hour days in the Rhode Island Great Swamp in over 100-degree heat, and in long pants and shirts to protect against ticks and biting flies. But I loved it. It made me feel strong and resilient. Moreover, identifying pollinators is important for bee conservation, so it was well worth the effort. Also in the lab, I worked with master students Amy Santiago and Katie Overstrom on a project studying slug herbivory using Brassica nigra plants. I adored working with the slugs and was often found cooing at them through the glass of their terrariums. In this project, I helped sift soil, make cues, and sort seeds. I became adept at washing slug slime off my fingers, but I also got to develop my attention to detail and reformulate my view on a conventionally yucky animal. My summer working outside with slugs, bees, and dirts was incredible, but it was also not without its challenges. Southern Rhode Island, like much of New England, is a hot spot for Lyme disease, a danger I got much more familiar with than I'd have liked. In July, I started presenting symptoms of Lyme. I felt afraid of the disease and also anxious about what this could mean for my research. Even though I had no way of knowing where and when I was bit, I began to question whether the experience I was having was worth the potential risks. However, my doctor was swift with my treatment, and I'm grateful to experience no lingering symptoms of my infection. In addition, my coworkers at URI were consistent in utilizing precautions and equipping me with the powerful repellents and wardrobe I needed to protect myself and quell my anxieties. Another challenge for me this past summer came in the form of my schedule. I love working in the lab and was grateful for the opportunity to be funded by Praxis, but I still needed to work part-time at Dunkin' Donuts for some supplemental income. Balancing my evening Dunkin' shifts with long days doing research in the swamp was tough, especially since I was sharing a car with my family. But what seemed like it would be a discouraging tightrope act only motivated me further to maximize my time doing research and learning from my mentors. Instead of feeling frustrated when I wasn't always able to come and go as I pleased, I felt excited to be dropped off early and picked up late from the lab. It allowed me to spend more time cooing at those slugs or practicing pinning my bees. And working in the Pricer lab provided me with more than just an amazing summer. It also gave me experience and connections in my field. As my internship ended, I reached out to an ecology lab at UMass Amherst under Professor Lynn Adler that's also studying bees. I knew that I was passionate about bumblebees, and I was hopeful about this UMass lab as an opportunity to deepen my knowledge of the genus. As a direct result of the bee identification skills I gained at URI, I was given the opportunity to work there with postdoc Jules Adler on bumble pinning and ID, exactly what I had dreamed of. This coming semester, I'll continue this work at UMass. In addition to equipping me with the background necessary to secure that position, my URI summer cemented my own future desires. I hope to continue my studies on pollinators in graduate school and eventually become a professor and researcher myself. I owe the certainty I have in my desired path to my summer at Pricer Lab. In the meantime, my research at URI has not yet ended. In fact, I wrote parts of this presentation sitting inside of the lab there. Over J-term this year, I popped in and out of URI's campus doing some independent work, organizing, labeling, and identifying the same bees I helped collect last summer. Once again, I never wanted to leave. This coming March, I'll get to practice my conference skills along with some other lab members at an event run by the Rhode Island Plant Insect Community Network. And while I'm enthusiastically applying for this coming summer's National Science Foundation funded REUs, or research opportunities for undergraduates, I'm grateful to know that I would also be welcome back at URI. So for my fellow students watching today, there's a few things I'd like to emphasize. Especially with funding getting more limited in the past few years, in STEM, securing an internship as a STEM undergraduate can often feel daunting and full of disappointments. This summer, I learned the importance of perseverance and self-advocacy. Although I received rejections from the internships I applied for, I made the decision to reach out directly to professors by cold emailing in the hopes of finding an opportunity, and I did. My ability to advocate for myself ended up making the difference not only between internship and no internship, but it also allowed me to push forward and secure more opportunities this year and possibly in the future. I also want to touch a little bit upon what it means to be a scientist and how my experience this summer changed my perspective on this. Coming to Smith, I felt completely out of my depth in my major, especially compared to some of my peers who worked long hours assisting with dynamic research initiatives here at Smith, skipped ahead to upper level courses, and seemed to grasp the material quicker and easier than I did. Many of them had volunteered in research labs in high school, and I felt inadequate with my Duncan job and lack of STEM AP course credits. In fact, it wasn't until the very end of the summer when I finally started to realize that my part-time job or lack of hiking boots didn't make me any less of a researcher. Fancy equipment or not, it's my passion for pollinators and plants and the excitement I bring with me when I'm studying them that makes me a scientist. So with confidence and experience under my belt, I can't wait to see what the future holds for me and my bumblebees. Special thanks go out to the Smith College Praxis program and Professor Evan Pricer, as well as my amazing URI colleagues and mentors, Ren Johnson, Amy Santiago, and Katie Overstrom. And last but not least, here's some pictures of me, the slugs, and the bees, and all other things from my adventures this past summer. Thank you so much.
Thank you, Chloe. That was fantastic. And I loved hearing about how your interest in biology sort of took off as soon as you got to Smith. That was a really cool part of your story. Finally, we're going to hear from Kerry Seekamp.
Hi, I'm just gonna share screen really fast here. Gotta get in presentation mode. Okay, I hope you all can see that. So I'm going to talk a little bit about my experience doing some summer math research and specifically my experience at the Duluth Research for Undergraduates. So a little bit about me. My name is Kerry Seekamp. I'm a senior here at Smith College. I'm a math major. And after Smith, I plan to get a PhD in mathematics, specifically in algebraic combinatorics. And I plan to pursue a career in mathematics research after my PhD. So before I got to Duluth, I did 2 other REU programs. I did the theoretical and application-driven mathematics REU at Texas A&M University Commerce, and I did the cryptography and coding theory REU at the University of South Florida. And in these REUs, I worked in a small group setting with a specific professor as an advisor, and these are just some pictures of me presenting those other projects I did. And then in addition to my summer research, I also have been participating in research here at Smith College since my freshman year with Professor Juliana Tomasco. So it's safe to say I had a good background in mathematics research before I got to Duluth. And so a little bit more about the Duluth structure and how it's different from a typical REU. So I was at Duluth for 8 weeks, and there were 9 other students there with me. And at Duluth, every student is given an individual research problem rather than a problem in a group setting. So I was given a problem, and in 8 weeks, hopefully I would solve it and then write a paper that could be published telling everyone the results. So this is kind of how the research process went. So 1 week before I got to Duluth, I was given a topic and some suggestions for potential research directions. So here you can see this looming email that I got a week before I got there that says your Duluth problem. And then inside of it, it had 2 papers here that I read through, and then it had some suggestions for potential directions I could go with this research. And then to help me along the process, Duluth has 2 wonderful directors, Joseph Gallion and Colin DeFont, who are pictured here. Colin is wearing shirts with Joe's face on them, if that tells you which one's which. And then in addition to the directors, we also had a group of graduate students that served as advisors. So anytime we ran into a problem with our project, we didn't know maybe where to move to next, we got kind of stuck. The advisors were there to give us ideas of where we could move forward, and they're also to help refine our final papers and help us with our presentations. In addition to the directors and the advisors who were really there permanently to serve and help us with our math, we also had a rotating cast of visitors. The visitors were typically previous program alumni. The Duluth REU has been running since the 1970s. So previous alumni have ranging experiences in math. Some of them are currently graduate students, some of them are still undergrads. Others of them, like the one I'm talking to in this photo here, currently work in industry at Google and have had long careers in mathematics research. So we got to talk to lots of people about their experience as mathematicians. And then we also got to use the visitors as sounding boards to talk about our problems as well, because they're all mathematicians and could provide us with lots of feedback about our presentations and maybe potential research directions and ways we could go. So each week, every Monday and Tuesday, every student would give a 15-minute chalk talk about the progress they had made that week. Since there were 9 students in my year, about half the students would present on Mondays, the other half would present on Tuesdays. Giving chalk talks was something that we practiced a lot. We had practice talks on Sundays to prepare for our talks on Monday and Tuesday. And it's really important as a mathematician, if you've ever been in a math classroom, mathematicians love to write on chalkboards. So getting good skills in communicating math via this medium was a big part of my experience at Duluth. And then we gave talks on Mondays and Tuesdays. And then halfway through our talk sessions on Mondays and Tuesdays, we would have a halftime show, which was kind of like a silly little break in between our talks. And on Mondays, the halftime shows were non-competitive. And on Tuesdays, the halftime shows were competitive. And if you won a competitive halftime show on a Tuesday, your name lives famously on a whiteboard in Duluth, Minnesota, on the Halftime Hall of Fame, which, since the program's been running for 50-ish years, is quite the Halftime Hall of Fame. You really want to be on it. So these are some pictures from some of the halftime shows. As you can see, they're very silly. Here's a picture of me with a banana because we did banana hunt. They wrote us a riddle and we had to hunt for bananas. This is me playing charades. It was also pajama day. We did our talks in pajamas. And then this is us laughing at Pictionary. And then on Wednesdays, we took a break from math and we went on a non-mathematical field trip as a cohort. So every Wednesday we would pack up our lunches, drive somewhere in Minnesota, have a picnic lunch, and then do a fun summer activity. The Duluth program really understands that giving students an individual research problem with the expectation of hopefully solving it and writing a paper in 8 short weeks is incredibly stressful and can make you kind of spend your whole summer inside. And they don't want you to do that. They want you to have a fun summer. So they plan a lot of activities that are fun and outside and get you outside and doing all the things you're supposed to be doing during a summer. So here, this is some of me and my friends doing alpine sliding. This is us crossing a river, and these are some pictures of us having picnics. We also did some other fun activities throughout the week. You can only do maybe about 4 hours of really productive math research a day before you're kind of just banging your head against a wall. So this is us at the swimming hole. We had a slumber party in the talks room, mostly because it had air conditioning and our dorms did not. We ate lots and lots of ice cream. It is a well-known fact that the number of papers you write while you're at Duluth is proportional to the number of malts you eat. We also did cooking collectives. So each week, a group of the students would get together and cook a giant meal for everyone in the program. Here's a picture of me looking very shameful because I spelled the word chocolate incorrectly, looking at these pancakes that I had made. And then I got to finish up my Duluth RU experience actually just a few weeks ago at the Joint Mathematics Meeting, which is the largest gathering of mathematicians in the world annually. And I got to give a talk discussing the work that I had done while I was at Duluth and discussing the paper that I wrote while I was there. And then I guess the big takeaways from my experience at Duluth, I wrote my first solo paper. So the other RUs that I had participated in, I did write papers at, and I have written a paper for the research I do at Smith. But all of those papers were written working with others. So I never, have written a paper, every word being my own from first page to last page. So this is my first experience doing that. There's the archive number if you're interested in looking at it. I gained skills in giving chalk talks and slideshow presentations, which is incredible skills to have as a mathematician. I gained a professional network of other mathematicians with all of the visitors who came, all of the advisors and the directors. I don't go anywhere to any conference or honestly anywhere in math and not run into people who did Duluth or know of the program or are connected to the program in some way. And then I had a fun summer and I made lifelong friends. I mean, the people I met at Duluth, I text on a daily basis about math and about life. So it was really an informative and amazing experience. And then I just want to wrap up by saying that the Duluth Summer Mathematics Research Program for undergraduates was hosted at the University of Minnesota Duluth with support from Jane Street Capital, the National Science Foundation, and very generous donations from Ray Sidney and Eric Websick. And then I'd like to thank the directors, Joseph Gallion and Colin DeFont, for this amazing opportunity, and then also all of the advisors for their support throughout the project. And that's it.
Thank you, Kerry. I never knew math could be so much fun. I was really happy to hear that they gave opportunities to really balance work and fun during your summer. That's fantastic. So now is the time we can take some questions from our audience. So if you have any questions for all of the panelists or just a single panelist you want more information from, feel free to drop those in the chat or message them to me directly. While you're all thinking of questions, I have a few we can get started with. So in STEM fields, we obviously expect that your internships will have lots of technical skills required and developed during the summer, but I'm curious, some of you touched on this, but what kind of soft skills do you feel were really important in your internships? So like communication, teamwork, problem solving, sort of those interdisciplinary skills that came into play during your experiences.
I could get started with that. One skill that I think was really, really helpful that I developed during the internship and kind of will keep for a very long time was over communicating, in the sense that I was constantly updating people on what I was doing. And I think sometimes when we do work, we tend to assume that if we do good work, it will be seen and it will be recognized. But sometimes in larger corporations, your manager is busy, your mentors are busy. So constantly letting them know what you're up to actually kind of keeps it fresh on their mind. And it paid off really well in the end because that was sort of good feedback that I got from them. So it's something that I definitely will keep doing. Yeah.
Thank you. Anyone else want to chime in about soft skills? Yeah.
I would say for my internship, because we did a lot of field work, the like soft skills aspect was maybe a lot more necessary than I expected it to be. So, because we were spending these long days out, sort of in the middle of nowhere, in some of our sites, like, if one of us were to pass out, like, it would only be a helicopter that could take us out of there, kind of thing. It required a lot of like trust in each other. And so, I needed to like be able to become close to my coworkers in a way that was professional. And I hadn't really experienced like being like having a closeness with someone that wasn't in like a friendship way, but in a more professional context. And so developing that sort of skill of not just getting along with, but bonding with my coworkers and having trust in them was something that it was an adjustment for me, but I feel like I learned a lot.
Oh, interesting perspective. Thank you. Anyone else want to chime in? All right.
I
Another.
can also-
Oh, yes.
Sorry.
Thanks.
Sorry. Something that my lab put a lot of emphasis on that was a bit field specific, but also a soft skill was the importance of like how to communicate your findings and like the best ways to present data for like a wide variety of audiences. So like of a really big amount of like the time I spent in Seattle was honestly like sending graphs like back and forth with my supervisor and changing very little things or like going over my presentation many times to make sure that it didn't just have the information that it needed to have, but it was understandable, that like it was clear from a single look what was going on. And I think even outside of data science, where obviously that's very important, it has helped me, like even with making this presentation, I was thinking about the things they had helped me with there.
I can confirm, as a person who's not familiar with STEM very much, you all do a great job of communicating what you did. I followed along with all of your presentations really well. This is another question I always like to ask. With any internship going into any field, I think it's easy to have sort of assumptions about that field or assumptions about how that work is going to go. But I'm curious if something surprised you about the field you worked in, that you didn't see coming, and either a pleasant surprise or not. I'm just curious if you were surprised by anything in the field.
I can talk about this a little bit. I was a little bit nervous going into my Duluth RU. Duluth is a really long-running RU and has an incredible list of previous participants, including Fields medalists, current Smith professors, professors at other institutions. So I was assuming I was going into a very serious mathematical environment, and it was going to be very do your work and that will be great. But instead, it was actually a very serious math environment, but a very silly social environment. I mean, at Duluth, all the students and the advisors and everybody live in the same building. So we were walking around and playing games all together all the time. And we were really encouraged to build a cohort, even more so than we were encouraged to just do our math. That was kind of just assumed that everybody who got into the program was really driven and going to do all the math on their own. And honestly, was more encouraged to be very social outside of that.
One thing that I'd say surprised me was the nature of an engineering role. So I applied for product management internships because I thought engineering would be too kind of like focused or like tunnel vision, like all you do is code all day. But because of like the misunderstanding that happened where I ended up being able to do engineering for a while, I was able to learn that depending on the team that you're on, you can actually be doing a lot more than coding. You can be doing a lot of people interaction. You can be doing a lot of planning, design, communicating with other teams, collaborating, and also getting to code, which was shocking for me because I thought all engineers do is code. And that new revelation is what allowed me to realize, wait, this is what I might want to do actually.
Anybody else want to chime in? Okay. Finally, unless more questions come in by chat, I wonder if you all have what's one piece of advice that you would leave students who are watching this with about how to look for internships in this field, or what is your parting piece of advice for those students?
I'm happy to start. I think anybody who's looking to get into research in math or really any field at Smith professors are dying to do research with students. So if you want to do research at Smith, send a couple emails, go knock on some professors' doors. They're really happy to talk about their research. It's really like the thing that they're most excited to talk about in the world. So go ask people about their research, and people are very excited at Smith to have students participating in research. So it's not hard to get a start in research at Smith, and then you can take those skills really elsewhere, and that's really applicable.
I would say kind of a similar thing, like don't be afraid to reach out. Like it can be daunting, like professors, are obviously, experts in their field and like for me, I was like wanting to learn all these things and professors were like the keeper of all the knowledge I wanted to have, right? But um, like just don't be afraid to reach out. Professors can be really busy, so you might not get a response to every email you send, but if you keep trying, you're going to find someone who, wants to have you on their team. And so that's what I would say is keep trying and keep reaching out.
Yeah, kind of bouncing off of what Kerry and Chloe just said, I think the word would be being proactive for me. Like, I think that sums up everything as well, being reaching out and not kind of waiting for things to come to you. And specifically for people who are interested in engineering or more of like industry and coding and software engineering, software development, I definitely would encourage you in the nature of being proactive to build your own stuff. Like maybe you're building applications, maybe you're building websites. If you're interested in data science, maybe you're doing your own independent research without it like being like, like professional research, because that gives you something to show recruiters in industries, or even something to show professors maybe that you're able to take the initiative and it's something that you're really passionate about.
Yeah, on kind of going off what everyone else has said, I feel like it's really important to remember, especially as an undergraduate, that like nothing is set in stone currently. And if there's a field or like an area that you're interested in, you shouldn't be kind of like scared away from it just because you don't already have all this experience in it, that you're not like like you don't have all these classes. Because I went into this experience with basically like one introductory biostats course where we didn't touch on like anything I actually worked with over the summer, and just an interest. And like through I was able to put that into my application instead of just saying like I just putting that in my application that I was interested and had this very cursory knowledge. I was able to get there because that's what these internships are for. They're not to like solve these massive problems. They're for you to learn and to find out more about the field. So I'd say just like don't be scared away, and if you're interested in something, like throw your hat in the ring.
All excellent advice. Thank you all. We don't have any more questions. I want to say thank you all for sharing not just your experiences, but also the aspects of your experiences that were about like adaptability, perseverance through that imposter syndrome, and just hard work. Like I think you really showed what you did this summer, and we appreciate you sharing all of that. So if no one has any more questions, this will conclude this Smith in the World STEM panel. A recording of this session and all 5 previous sessions will be available on our YouTube channel in the coming week or so. So thank you again to our wonderful panelists. Another round of applause for them. And thank you to our audience for attending. And I hope you all enjoyed this session as much as I did. Thank you. Good night.